Welcome to the retake video for section I.2. As a quick review, last time we talked about adding zeros to the board doesn't change the board's value at any point. So remember, you can add as many zeros as you want. You could subtract as many zeros as you want. In fact, your board has an infinite number of zeros on it before the problem starts. Okay, so when we move back to these problems, as a reminder, we always want to break them down into 3 steps. Step 1, we always want to look at the first number that we're working with. Step 2 tells us if we're adding or taking away from the board. And step 3 tells us what we are adding or are taking away from the board. Therefore, when we start with this first problem, we are looking at starting with a positive 1. So we take our positive 1, that's how our board starts. Step 2 tells us that we are adding to this board because it's an addition problem, but we are adding 3 negative chips to the board. So we take our 3 negative chips and we add them to our board. Now, in order to solve this problem, we need to have only one type of chip on the board at a time. I know that if I take these 2 chips together, this is a 0. Therefore, they can be ignored. And we are left with 2 negative chips. Therefore, 1 plus negative 3 is equal to negative 2. Moving to the next problem, we are going to start with our first number once again. In this case, our first number is negative 4. So we are going to put 4 negative chips on the board. 1, 2, 3, and 4. Now for this problem, we are taking away two positive chips. We do not have any positive chips on the board to take away, so that means we have to add 2 zeros to the board. So there's our first 0. And here's our second. So the board's value is still negative 4. The board's value has not changed. But we now have 2 positive chips to take away. So we get rid of 1 and 2. And we are left with 6 negative chips left on the board. Let's keep going. This one is a kind of an interesting problem. We start with positive 2. Okay, so we get our 2 positive chips and we get them on the board. And this time we need to take away three positive chips. Now the problem here is we only have 2 positive chips to take away, so our answer has to be negative. But in order to get that third chip to take away, I'm going to add a 0 to the board. So now our board is still equal to positive 2, but we can take away 3 positive chips. So I take away 1, 2, 3 positive chips, and I am left with an answer of negative 1. Okay. So now we have negative 3 plus negative 5. So we are going to start with 3 negatives. So I'm going to go 1, 2, 3. And this time, I need to add 5 negative chips to the board. So I'm going to simply get 5 negative chips. I'm going to drag, whoops, I messed that up. I'll just do it this way. Try to get fancy. Couldn't make it work. Everyone knows that I shouldn't try to get fancy. So I added my 5 negative chips to the board. Now we only have 1 type of chip on the board, which is negatives, and we have 8 of them. So our answer is negative 8. Okay, so let's jump down to here. So we want to start with negative 3, so 3 negative chips to the board. and we need to add 3 positive chips to the board. Okay? We do not have one type of chip, but we do have 3 zeros. 1 0, 2 0, 3 0. There's nothing else left on the board, therefore our answer has to be 0. Not too bad. And let's do one last problem. So I want to start with 1 negative chip. Now this time I need to take away three negative chips. Now I have 1 negative chip that I can take away right now, but in order to get 2 extra negative chips, I have to bring in 2 zeros into the problem. So the board's value is still -1. That hasn't changed. But now I have the ability to take away 1, 2, 3 negative chips. That means I am left with an answer of +2. As always, if you have any questions, make sure you let me know, and let me know your score that you got at the end of this video.